The demand for training in the operation of additive manufacturing equipment is increasing at an extremely fast rate. As companies make the decision to incorporate or outsource AM for prototyping or manufacturing of products, the need for appropriately skilled technicians, operators, and engineers becomes immediate. At the same time, the lack of available workforce has been identified as one of the greatest barriers to adoption and implementation of AM. At Carnegie Mellon University, the Next Manufacturing Center has partnered with the Entertainment Technology Center and the Human-Computer Interaction Institute to develop the AM Training Tutor, a tool that enables engineering students and professionals to develop the AM knowledge and hands-on skills needed for the growing AM field. Instructors and trainers know that it is not practical to have a group of more than a few students and an instructor interacting with an AM machine. The AM Training Tutor expands the audience and makes the training accessible to a larger group. While our interactive tool will not replace in-person training on actual AM machines, it allows reduced time in front of the equipment for each user and increases the efficiency of instruction at the machine. Besides being flexible and convenient, it also provides a safe virtual environment for learning before users work with the actual machine. The interdisciplinary team behind the AM Training Tutor brings together deep knowledge of AM machines and processes from the Next Manufacturing Center, virtual reality design and development expertise from the Entertainment Technology Center, and learning science and educational technology expertise from the Human-Computer Interaction Institute. The AM Training Tutor employs well-founded learning science principles to the instructional task. It categorizes the operations into groups to make it easy to navigate and brings state-of-the-art technology to the table, in this case, virtual reality. The AM Training Tutor is intended to be used as part of an instructional sequence. The progression includes lecture by a qualified trainer, followed by use of the AM Training Tutor by users individually, and finally, practical instruction at the machine where the training provided by the AM Training Tutor, which includes both declarative and procedural instruction, is reviewed. Both of these instructions use CTAT, the Cognitive Tutor Authoring Tools, a tool suite that enables learning by doing. It acts as a back-end server for sending the data related to instructions and feedback. It also serves as a tool to recall student behaviors and analyze the data in the future. The declarative instruction of the AM Training Tutor helps users learn the required safety procedures and identify the various components of a specific AM machine. Users are shown visuals of the equipment and are prompted to identify the important components of the machine. Using an underlying intelligent tutor, they can request hints if needed and are provided feedback on the accuracy of their work. Declarative instruction is PC and internet-based and can be accessed by users from their own computers. The procedural instruction for the AM Training Tutor guides users in learning the necessary steps for setting up the machine for 3D printing. This is supported by a virtual reality system that prompts users step by step to set up the equipment in preparation for a build. Users can virtually grab machine components and move them from one location to another, install and level the build plate, load the powder, and perform all of the actions needed for machine setup. This part of the instruction has a high degree of fidelity to actual machine setup and provides hints if requested and feedback, typically in the form of highlighting objects on and near the machine for required setup steps. While the initial deployment of the AM Training Tutor is specific to the EOS M290 laser powder bed machine, it was designed in a way that allows development of the tool for other equipment in a shortened amount of time. This can include other AM equipment as well as advanced manufacturing machines for which in-person training is a challenge.